Today we will talk about the double angle and the half angle formula. Instead of thinking of these as new sets of formula, we would first see how to determine and derive these formulas from the set of formulas that we have learned in our last video lecture, where we have talked about the sum and difference of trigonometric ratios. So let's think about what was the formula for sine of alpha plus beta. Sine of alpha plus beta was sine alpha cosine beta plus cosine alpha sine beta. What if alpha and beta are equal to each other? Then I can rewrite the same formula as sine of alpha plus alpha, which is sine of alpha cosine of alpha plus cosine of alpha sine of alpha. And I see that these are the same quantities twice, so I simply call it 2 sine alpha cosine alpha. And that determines the formula, the double angle formula for sine. Sine of 2 alpha is 2 sine of alpha times cosine alpha. Similarly, one can determine the formula for the double angle formula for cosine. So start with the cosine sum formula. Cosine alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. So think about what we have done last time. Make it cosine alpha plus alpha. So that is equal to cosine alpha times cosine alpha minus sine alpha times sine alpha. So cosine of 2 alpha is equal to cosine square alpha minus sine square alpha. So the obvious question is, how about the double angle formula for tangent? And I do the same thing. I say, well, tangent of alpha plus beta was the ratio tangent alpha plus tangent beta on the top, and the bottom was 1 minus tangent alpha tangent beta. So what we do now, we change alpha and beta and make them equal to each other. So tangent alpha plus alpha is equal to tangent alpha plus tangent alpha, this time on the top, over 1 minus tangent alpha times tangent alpha, which is 2 tangent alpha over 1 minus tangent squared alpha. So that's the double angle formula for tangent. So I get tangent 2 alpha is equal to 2 tangent alpha over 1 minus tangent squared alpha. How about the half angle formula? So if alpha is given, can we find a formula that will determine alpha over 2's ratios, trigonometric ratios for us? So again, we would like to use the similar set of formulas to do the work for us. So let's see how we can do that. So where we will start is with the double angle formulas, but we will rewrite them in a little different way. So remember, the formula was sine of 2 alpha equal to 2 sine alpha cosine alpha. And when I said I will write the same formula, just a little different way, I'm going to write this 2 alpha as alpha, and I'm going to write the alpha as half of alpha. So that will be a double angle formula where the original angle is alpha over 2. And if I do the same trick with cosine formula, I actually get the half angle formula for both sine and cosine. So let's do that. We will start with, as we have talked about, double angle formula for cosine. So cosine of 2 alpha, but instead I will write cosine of alpha, and that's going to be cosine square. Instead of alpha, I have to have half of that, so cosine square alpha over 2 minus sine square alpha over 2. So first, we're going to generate the half angle formula for sine. So what I do, I write it one more time, cosine alpha. Instead of cosine square, I use the Pythagorean identity and write it as 1 minus sine squared alpha over 2. So that will be an equation in terms of sine square alpha over 2. All we have to do is subtract 1 from both sides. So cosine alpha minus 1 is 2 sine square alpha over 2. And they are negative. So now I can say, well, divide both sides by negative 2 to solve it for sine square alpha over 2. And I get sine square alpha over 2 equal to cosine alpha minus 1 over negative 2. So as you can imagine, I can simplify that and I can say sine square alpha over 2 equal to 1 minus cosine alpha over 2. So of course, to solve it for sine alpha, I need to take the square roots on both sides. So my solution should be absolute value of sine alpha over 2, and that's very important for you to remember, because depending on which quadrant alpha over 2 is going to land, your answer could be positive or negative for sine alpha over 2 is equal to the square root of 1 minus cosine alpha over 2. Okay, so that makes the question that can I do the same thing for cosine half angle? Well, I start at the same point. I say cosine alpha equal to cosine square alpha minus sine square alpha. This time I want the half angle formula for cosine. So I change sine square alpha over 2 to cosine square alpha over 2, but using the Pythagorean identity. So I call it cosine square alpha over 2 minus 1 minus cosine square alpha over 2. That's your sine square alpha over 2. Distributing the minus and combining like term, I will get 2 cosine square alpha over 2 minus 1. So add 1 on both sides and you get cosine alpha plus 1 equal to 2 cosine square alpha over 2. As usual, divide both sides by 2 and you get cosine square alpha over 2 equal to cosine alpha plus 1 over 2. Take the square roots on both sides to get cosine alpha over 2 by itself. And you will get absolute value of cosine alpha over 2 equal to square root of 1 plus cosine alpha over 2. And that will be the half angle formula for cosine. Again, remember, depending on in which quadrant alpha over 2 is going to land, your value for cosine alpha over 2 will be positive or negative. So absolute value is absolutely necessary. Okay, so my final step is to talk about the half angle formula for tangent. So what I do, again, a little more manipulation. Remember, you have the formula for sine and cosine. So what you do, you write absolute value of sine alpha over 2 over absolute value of cosine alpha over 2. Remember, that's going to be tangent equal to the square root of 1 minus cosine alpha over 2 over square root of 1 plus cosine alpha over 2. And that's precisely is going to determine the formula. So I will say absolute value of tangent alpha over 2 is equal to square root 1 minus cosine alpha over 1 plus cosine alpha. Because the 2 and the 2 from the top and the bottom will cancel each other. And again, depending on which quadrant your alpha over 2 is going to land, you will determine the sign of tangent alpha over 2. So these are your half angle and double angle formulas. Depending on the problem, depending on the angle, we will determine which formula to use and what sign to use. Okay, so we're going to start working on our actual problem. The beginning of the lecture note has all the formulas given there for you. Use the figure to find the exact value of each trigonometric function, sine 2 theta. So remember, first I'm going to find out sine of theta, and sine of theta is simply going to be 3 over pi, that's opposite over hypotenuse. Cosine of theta is adjacent, so 4 over 5, and tangent of theta is opposite over adjacent, so 3 over 4. Sine of 2 theta is 2 sine theta cosine theta. You have the value for sine and cosine, so you say 2 times 3 over 5 times 4 over 5. Which is 24 over 25. Answers your question. Cosine 2 theta, you can write it as cosine square theta minus sine square theta. So cosine square theta is 4 square, so 16 over 25. Sine square theta is 3 square, 9 over 25. and I get 7 over 25 for cosine 2 theta. Tangent 2 theta is the third one, and it is simply 2 tangent theta over 1 minus tangent square theta. And I know 2 tangent theta will be 2 times 3 over 4 over 1 minus 3 squared, which is 9, 4 squared, which is 16. So I get 6 over 4 on the top, 2 times 3 is 6, all over 16 minus 9 is 7, so 7 over 16. Dividing by a fraction means multiplying by its reciprocal, so I do 16 over 7, and then I simplify, I cancel the 4, I divide 16 by 4, I get a 4. 4 times 6 is 24, so my answer is 24 over 7. And that answers my question for the double angle formulas for sine 2 theta, cosine 2 theta, and tangent 2 theta. Very simple. We'll carry on. Our next objective is to understand similar question. This time it says sine theta is 2 over 7 and theta lies in quadrant 2. Find sine 2 theta, cosine 2 theta, and tangent 2 theta. So what I will do, I will ignore the quadrant at this point. Sine 2 theta, just write down the formula. This is going to be 2 times sine of theta times cosine of theta. So I will get 2 times, remember sine of theta is 2 over 7, so now I need cosine of theta. That is where you're going to need the quadrant 2. How come? Well, remember, sine of theta being 2 over 7 and the angle being in the second quadrant, you can immediately draw the triangle, opposite being 2, hypotenuse being 7, and you are looking for x. So I can say 2 squared plus x squared is equal to 7 squared. That means x squared equal to 49 minus 4. So x squared equal to 45. And then I can take the square roots on both sides. So I get absolute value of x equal to square root of 45, which I can write as square root of 3 times 3 times 5. So 3 can come out, and absolute value of x will be 3 square root of 5. So x is going to be negative 3 square root of 5 because my x is in the second quadrant where it is negative. So that tells me how much is cosine theta, and I will say it is adjacent, so minus 3 square root of 5 over 7. So I get 4 times 3, so that's a negative 12 square root of 5 over 7 as the sine 2 theta. Cosine 2 theta, you can say that this is cosine square theta minus sine square theta. So when I do cosine square theta, that will be negative 3 square root of 5 over 7 squared. So it is going to be positive. Top is going to be 45, bottom is 49. And minus 2 squared, which is 4, over 7 squared, which is 49. And I get 41 over 49 as the cosine 2 theta. Tangent 2 theta. Remember, tangent is opposite over adjacent. So it's 2 over negative 3 square root of 5. So let me first write down what is tangent theta. It's negative 2 over 3 square root of 5. So the formula says this is 2 tangent theta over 1 minus tangent square theta. So I get to say 2 times 2 over 3 square root of 5 over 1 minus the square of 2 is 4. The square of 3 square root of 5 is going to be 45. And I have to be careful about one other thing. Tangent theta is negative, so I must have a negative sign here. So, but when you square, it doesn't show up, so that's good. And you get negative 4 over 45, 3 square root of 5, I'm so sorry. 3 square root of 5 on the top, and the bottom is 45 over 45. So 45 minus 4 is 41 over 45. So dividing by a fraction means multiplying by its reciprocal. So I will do that. 45 over 41. So remember, when you cancel 3 square root of 5 and divide 45 by 3 square root of 5, you get 3 square root of 5 because the square of 3 square root of 5 is 45. So my answer is going to be negative 12 square root of 5 over 41. And I have worked out every single trigonometric relations for the double angle. Similar problem, this time cotangent is given, and that is 8, and theta is in quadrant 3. So easiest way, draw your point, negative 8, quadrant 3.
cotangent is adjacent over hypotenuse. Because it is 8, easier to think about as 8 over 1, and it's adjacent over opposite, my mistake. So because it is in third quadrant, both x and y are negative. So that must be negative 8 adjacent. This must be negative 1, the opposite. So I need the hypotenuse, which you know that we refer as the radius. So the radius square is negative 8 square plus negative 1 square. And we assume radius is always positive. So r square being 64 plus 1, which is 65, I would say r is equal to square root of 65. And we cannot simplify any further, so that will be my r, square root of 65. And then I'm going to use these values to find out my trigonometric ratio, and then use them to do the double angle formula. So first, I need to know sine theta. Sine of theta is opposite, so negative 1 over square root of 65. Cosine of theta is adjacent, so negative 8 over square root of 65. Tangent theta is the ratio of them, or you can say it is opposite over adjacent, so that's negative 1 over negative 8, so this is 1 over 8. Sine of 2 theta, formula is 2 sine theta cosine theta. So I get 2 times negative 1 over square root of 65 times negative 8 over square root of 65, and then I get that is equal to negative times negative is positive, so it is 16 over 65. Cosine 2 theta, well, that is going to be cosine square theta minus sine square theta. So that is negative 8 over square root of 65, which is the cosine square, minus negative 1 over square root of 65 square. 8 squared is 64, and it's positive. And I'm subtracting 1 over, and the bottom should be 65, no longer square root because you squared it. So, and the other one is 1 over 65. Subtracting, I get 63 over 65 as cosine 2 theta. Alright, so finally we're going to find out tangent 2 theta. So remember the formula, it's 2 tangent theta over 1 minus tangent square theta. So I get 2 times, if you remember what tangent theta was in the work that we have done, it was 1 over 8 for this problem. So I'm going to use the value 1 over 8. And then I will have 1 minus 1 over 8 squared. So I get 2 over 8 on the top. The bottom is 1 minus 1 over 64. So at the top I can call it 1 over 4. On the bottom, 64 minus 1 is 63. So 63 over 64. So 1 over 4 times 64 over 63. Then 4 divides 64 gives you 16. And you get 16 over 63 as the tangent 2 theta. At this point, I want to notice one other thing. So I wanted to know tangent of 2 theta. Remember, this is sine of 2 theta over cosine of 2 theta as well. So let's see how much is sine of 2 theta that we have found out previously. We found sine of 2 theta as 16 over 65 and cosine of 2 theta is 63 over 65. So I will say 16 over 65, 63 over 65. Again, you can cancel the 2 65s from the bottom and get 16 over 63. So this is one other way. Instead of using the double angle formula for tangent, you can find out what will be the double angle formula just using sine and cosine and the ratio. Write each expression as the sine, cosine or tangent of a double angle, then find the exact value of the expression. So the first one clearly is the double angle formula for sine. So I will say it is sine of 2 times the base angle, which is 45 degrees. So 2 times 45 degrees is 90 degrees. So this is sine of 90 degrees, and that's 1. The second one is cosine double angle formula. So you will say cosine 2 times 22.5 degrees. So that's cosine of 45 degrees. Cosine of 45 degrees is square root of 2 over 2. 2 cosine square 5 pi over 8 minus 1. That's also the double angle formula for cosine. If you remember when I was showing you how to derive the formulas, we actually derived it. I just want you to understand and see it one more time. So remember when we did the double angle formula for cosine, we said that cosine of alpha is 2 cosine square alpha over 2 minus 1. So that one you can think of as cosine of 2 theta is equal to 2 cosine square theta minus 1. So it's a double angle formula for cosine. Similarly, if you go back to the sine, then remember where we had the formula for sine cosine alpha minus 1 equal to minus 2 sine squared alpha over 2, or you can think of that as cosine of 2 theta minus 1 equal to 2 sine squared theta with a negative, or I can make it better, cosine of 2 theta equal to 1 minus 2 sine squared theta. That is also the double angle formula for cosine. So actually cosine has 3 different forms of the double angle formula, and that's the only trigonometric ratio that is so. So what I do, first I remind you these formulas. They're the same, 3 different forms. You can write it as cosine square theta minus sine square theta. Then using Pythagorean identity, I can make it 2 cosine square theta minus 1. Using Pythagorean identity, I can make it 1 minus 2 sine square theta. All of them are double angle formulas. So when I see 2 cosine square 5 pi over 8 minus 1, I write it as cosine 2 times 5 pi over 8 minus 1, which is cosine 5 pi over 4 minus 1. Well, 5 pi over 4, it should be 2 pi over 4, 4 pi over 4, 5 pi over 4. So in the third quadrant, the reference angle is pi over 4 clearly. So cosine 5 pi over 4 should be negative in third. So minus cosine pi over 4 minus 1. And that's minus square root of 2 over 2 minus 1. And that is the answer to my question. I don't know why I'm writing this minus 1. I can keep writing it because the formula is just 2 cosine square theta minus 1 equal to cosine 2 theta. So that is the answer to the question. Alrighty. 2 tangent pi over 2 over 1 minus tangent square pi over 2. So that's clearly the tangent double angle formula. So I'm going to get tangent of 2 times pi over 2, which is tangent of pi, and that should be equal to 0. So if you want to input the value in this thing, remember 2 tangent pi over 2 is going to be undefined because tangent pi over 2 is going to be undefined. So you cannot literally put values in there, but what you can do, you can use the double angle formula and compute this. Alrighty. Let's try some other problems. This time we're not having a specific angle. We have an arbitrary x and we want to understand what is tangent of 2 cosine inverse x over 4. So what we would like to think that as this cosine inverse x over 4 is my theta. So I will get tangent of 2 theta. That's what I'm trying to find out. Remember what I said. Cosine inverse x over 4 is theta, so x over 4 is cosine theta. That reminds you that depending on the sign of x, either positive or negative, I will get the cosine value in the first or in the second quadrant. But because we don't know the sign of x, I don't have to worry about it. I will just draw the picture in the first quadrant. So I'm assuming x is positive. So what I do, I will say, and for cosine to make sense, it must be less than or equal to 4 as well. And this we can say less than or equal to 0. But I want to do the work in the first quadrant. So what I will say, because it is cosine, the adjacent side is x, the hypotenuse is 4, and I want to know how much is the y. Remember, y is going to be positive this time. So y squared plus x squared is equal to 16. So y squared is 16 minus x squared. As we have talked about, I want y to be positive, so y is going to be square root of 16 minus x squared. Well, so now I know that I want to find tangent 2 theta, which is in formula 2 tangent theta over 1 minus tangent square theta. So what is tangent theta? Well, tangent theta is opposite over adjacent, so that's square root of 16 minus x squared over adjacent is just x. Put that in place of tangent theta, so you get 2 times square root of 16 minus x squared over x all over 1 minus, now you're taking the square of tangent, so it's 16 minus x squared over x. And squared. And then I simplify, so I will get 2 times square root of 16 minus x squared over x on the top. On the bottom, I will get x squared minus 16 plus x squared over x squared, which when I simplify, remembering the fact that I'm dividing by a fraction, I will get 2 square root of 16 minus x squared over x times, see, it is x squared plus x squared, so that's 2x squares minus 16 over x squared, but because I have to take the reciprocal, so let me actually write down one more step that will be easier for us to understand. So as I said, combine the like terms, so get 2x squared minus 16 over x squared. Then you said this is equal to 2 times square root of 16 minus x squared over x times reciprocal of the bottom fraction is x squared over 2x squared minus 16. So the only cancellation is between x and x squared, and when I do so, I get 2 times x times square root of 16 minus x squared all over 2x squared minus 16. So I see that I can now cancel 2 from top and bottom, and that answer should be x times square root of 16 minus x squared over x squared minus 8. And that should be the final answer to my question. So we'll do a similar problem. This time tangent x is negative 1/3, cosine x is greater than 0. I want to know the double angle formulas. So 2 things, tangent negative, cosine positive must be in 4th quadrant. So you are here, draw the quick right angle triangle. Tangent is opposite, so that should be negative 1. And hypotenuse over adjacent, which is 3. So I need the hypotenuse, which is the radius. So r squared is negative 1 squared plus 3 squared. And that's 1 plus 9, which is 10. R is always positive, so that's square root of 10. So then I'm going to go ahead and write down my trigonometric ratio for sine x, which is going to be opposite over hypotenuse. Cosine x is adjacent over hypotenuse. Tangent x is opposite over adjacent and negative 1/3. So sine 2x, remember the formula is 2 sine x cosine x. So I get 2 times sine x, which is 1 over square root of 10 with a negative, so I will put it inside parentheses, times cosine x is 3 over square root of 10. So my answer is going to be negative. 2 times 3 is 6 over 10, and then I can simplify as negative 3 over 5, and that's sine 2x. We now do cosine 2x. So that will be cosine square x minus sine square x. So I get 3 over square root of 10, then square it, minus negative 1 over square root of 10, and square it. So I get 9 over 10 minus 1 over 10, which is 8 over 10 simplified. That's 4 over 5, and that's your answer for cosine 2x. Tangent 2x, remember I can just do the ratio of sine and cosine or use the double angle formula. Let's do the ratio, that's easier. So it is sine of 2x over cosine of 2x. So I get 3 over 5 over 4 over 5, and that is equal to 3 over 4. If you have any doubt, you can just go ahead and do the double angle formula for tangent, which is 2 tangent x over 1 minus tangent square x, and I'm pretty sure we'll get the same result. So it's 2 times negative 1/3 over 1 minus negative 1/3 squared, which is negative 2/3 on the top. The bottom is 1 minus 1 over 9. So 9 minus 1 is 8. So I get negative 2/3 over 8 over 9. Well, dividing by a fraction means multiplying by its reciprocal. So it's 9 over 8. And then when I simplify, 2 cancels 8 gives you 4. 3 cancels 9 gives you 3. So my answer is negative 3 over 4. And that answers my question. So And that's precisely what we wanted to do. Oh, actually, if you remember, sine was negative 3 over 5, and I forgot that when I was doing the ratio, so that should be a negative here. So my answer should be a negative 3 over 4. I mean, if you want to do it one more step, so then this is the reciprocal, which is negative 3 over 4. So answers my question. So tangent 2x is negative 3 over 4. Sine of 15 degree is 1/2 times square root of a minus square root of b. Then by using half angle formula, find a. So sine of 15 degree, and I'm telling you to use the half angle formula. So remember what happens. Absolute value of sine alpha over 2 is square root of 1 minus cosine alpha over 2. That's the formula. Now, I want to know sine of 15 degree, which is half of 30 degree. So I can say absolute value of sine 30 degrees over 2 equal to square root of 1 minus cosine of 30 degrees over 2. Now sine 15 degree will be positive because 15 degrees is in the first quadrant. So I can simply take the absolute value and just do the positive answer. So that will be 1 minus, now cosine 30 degree is going to be square root of 3 over 2, and that is over 2. So this calculation is something that we will pay attention now. So see what I have. I have square root 2 over 2, that's your 1, minus square root of 3 over 2, all over 2. So that is equal to square root 2 minus square root of 3 over 2 times 1/2. Why 1/2? Because 2 is 2 over 1. So dividing by 2 over 1 is multiplying by 1/2. So I get square root of 2 minus square root of 3 over 4. And I have to give this thing the form of 1/2, so I can bring out this 4 and do the square root and write it outside, and it will be 1/2, and I will get square root of 2 minus square root of 3. And then identify with a and b. So a must be 2 units and b must be 3 units. That will make sense and will be identified with 1/2 square root of a minus square root of b. Answers my question? So we have talked about the half angle formula already, so I'm going to skip these things and go ahead and start working on our half angle formula problems. Sine 5 pi over 12, and I'm going to find it out using half angle formula. So as soon as I say sine 5 pi over 12, you draw it in the standard position first to understand which quadrant you should be in. So remember 5 pi over 12 is not a standard angle. So probably it will help us if I change it to the degree measure. So what I will do 5 times pi and I will divide it by 12. This is the radian measure, multiply 180, divide by pi. So 75 degrees. So clearly this is in the first quadrant. So that's what I'm going to first say. So that is 5 pi over 12 in the first quadrant. So that is going to be positive. So the half angle formula will tell you I don't have to write the absolute value anymore because it is in the first quadrant. I know that my answer is going to be positive. And this is going to be 1 minus cosine alpha. Alpha is double of this. So I will say 2 times 5 pi over 12 over 2, which is square root of 1 minus cosine of 5 pi over 6 over 2. To know the value of 5 pi over 6, I have to draw it in the standard position. But that's easy because this is 3 pi over 6. 2 more, so that's 5 pi over 6. And remember, this is in second quadrant, so cosine is negative and the reference angle is pi over 6. What's my point? I said this is square root of 1 minus cosine pi over 6. Because 5 pi over 6 is in the second quadrant, cosine will be negative there, over 2. And then you put the values in. So I will get, first and foremost, 1 minus times minus is a plus. Cosine pi over 6 is square root of 3 over 2, and that over 2, all of that under square root, so just like the last one. So I get 2 plus square root of 3 over 4, which I can write as 1/2 square root of 2 plus square root of 3. And that will be the sine formula that I wanted to see. And that answers my question. Okay, so we'll carry on, see what else we can do. I want to do tangent 22.5 degrees. So remember, you were already in the first quadrant, so don't have to worry about the absolute value. I just have to write it as, in the formula, square root of 1 minus cosine alpha. But alpha will be double of this half angle, which is 45 degrees. And then over 1 plus cosine of 45 degrees. And then simplify. So square root of 1 minus square root of 2 over 2 over 1 plus square root of 2 over 2, which is equal to square root of 2 minus square root of 2 over 2 over 2 plus square root of 2 over 2. You can cancel the two 2's from the top and bottom, and you get square root of 2 minus square root of 2 over 2 plus square root of 2 as your final answer. Answers your question, and we will carry on to the next problem, where we're finding cosine of 67.5 degrees. Again, 67.5 degrees is in the first quadrant, so it's positive. I just use the formula. 1 plus cosine of double of 67.5 degrees, which is going to be 135 degrees over 2. And that is 1. So cosine 135 degrees is in the second quadrant. So I will need the reference angle. So it is here. Reference angle is 180 minus 135, so 45 degrees. Remember, in second quadrant, cosine is negative, so that's minus cosine 45 degrees, and that is over 2. So I get square root 1 minus cosine 45 degrees square root of 2 over 2, all over 2. So I get square root of 2 minus square root of 2 over 2 over 2, which is square root of 2 minus square root of 2 over 4. And that will be the answer to this question. We write it one more time. So 2 minus square root of 2 over 4. Answers your question. So as usual, you can bring up this 1/4 as 1/2 outside the square root and write this 2 minus square root of 2. Alright. Okay. Tangent of 7 pi over 8 is our next example. So again, 7 pi over 8, your question is which quadrant you should be in. And again, 7 pi over 8 not being a special angle, I have to use the calculator to know the degree measure. All I have to do is 7 times pi divide by 8 and then multiply 180 and divide by pi to make it degree. That's 157.5 degrees. So I'm in the second quadrant. Okay? So I will say I'm here, and that must be 7 pi over 8. Now remember, this time tangent second quadrant is negative. So in the formula, you will say minus of square root of the formula. When I'm removing the absolute value, I take the negative value. And that is 1 minus cosine alpha. Alpha is double of 7 pi over 8, which is 7 pi over 4. So bottom is the same. That's 1 plus cosine 7 pi over 4. So what is 7 pi over 4? Well, remember, for 7 pi over 4, I'm doing the special angle pi over 4. So 2, 4, 6, 7. So I was in the fourth quadrant, and the reference angle is, so this is 7 pi over 4. So the reference angle is just pi over 4. Fourth quadrant cosine is positive, so I can simply write it as square root of 1 minus cosine pi over 4 over 1 plus cosine pi over 4. And I know that both of them are square root of 2 over 2. So 1 minus square root of 2 over 2 over 1 plus square root of 2 over 2. Simplification. So I can write it as square root of 2 minus square root of 2 over 2 over 2 plus square root of 2 over 2. I can cancel the two 2's in the bottom for both top and bottom and get the answer as 2 minus square root of 2 over 2 plus square root of 2. And that is going to be the answer, with the exception of all of these are going to be negative because your original tangent is in the second quadrant, and that is a negative answer. Okay, so we're done with this. Use the figure to find the exact value of each trig function. I want sine theta over 2, and it looks like, since everything is positive, we are in the first quadrant. So theta over 2 is also in the first quadrant. How come? If theta is in the first quadrant, you can say that it is between 0 and pi over 2. So dividing all of that by 2, you get 0 less than theta over 2 less than pi over 4. But that is also less than pi over 2. So you're still in the first quadrant. So sine theta over 2 is just the positive 1 minus cosine theta over 1 plus cosine theta. And cosine theta can be found from the triangle. It's adjacent over hypotenuse. So cosine theta is 4 over 5. So I get square root of 1 minus 4 over 5 all over 1 plus 4 over 5, which when simplified, I get 5 minus 4 over 5 over 5 plus 4 over 5, and I get square root of 1 over 5 over 9 over 5, and that is equal to square root of 1 over 9, which is 1/3. So that is the required sine theta over 2. I did the tangent theta over 2. I'm so sorry. I wanted to do the tangent theta over 2. So sine theta over 2, it's still, I am in the first quadrant, so I'm positive. So the formula is a little different. It is square root of 1 minus cosine theta over 2. And I have the premise to the problem. I know the values. It's 1 minus 4 over 5 over 2. So 5 minus 4 over 5 over 2 and under square root. 1 over 5 over 2 over 1. So 1 over 5 times 1/2, and that is square root of 1/10. You can also write it as 1 over square root of 10 because square root of 1 is 1, or you can write it as square root of 10 over 10 when you rationalize the denominator. All of them are right answers. Okay? Same problem, but this time you want cosine theta over 2. So cosine theta over 2, remember, is going to be positive because theta over 2 is in the first quadrant. And it is 1 plus cosine theta over 2. So that's square root of 1 plus 4 over 5 over 2, which is 5 plus 1, 4 is 9 over 2. 9 over 5 all over 2. So I can write one more step for that. You can say 5 plus 4 over 5 over 2, which is square root of 9 over 5 over 2 over 1. That's your 2, which is 9 over 5 times 1/2. And that's square root of 9 over 10. I can call it 3 square root of 9 over square root of 10, or 3 square root of 10 over 10. And the final one is tangent of theta over 2. So remember, I have already shown you that. What if I do sine theta over 2 over cosine theta over 2? Because I found both of them. Sine theta over 2, as far as I remember, was square root of 10 over 10. And this one is cosine theta over 2. So 3 square root of 10 over 10. So I get square root of 10 over 10 times 10 over 3 square root of 10. And I cancel the square roots and the 10. So I get 1/3. And if you recall, my answer for tangent theta over 2, which I did without using sine or cosine, just using the half angle formula, was 1/3 as well. So I did it right again. Alrighty, so that answers this question. Now I have secant, and I know that my theta is in quadrant 2. I'm going to find the half angle. So quadrant 2, secant is hypotenuse over adjacent. So adjacent must be -5 because hypotenuse is always positive. And I want to know why. Remember, in the second quadrant, y is positive. So y squared plus 25, that's -5 squared, is 13 squared, so 169. So y squared is 169 minus 25, which is 144. Then I take the square root. I get absolute value of y equal to 12. But because y is positive in second quadrant, my y is 12. So I will say cosine theta, that's the only thing I need for any trigonometric ratio, which is going to be half angle of any trigonometric ratio, and that is going to be cosine theta is adjacent, so that's -5 over hypotenuse of 13. Now I do the manipulation. Theta is between 0 and pi because it is in the second quadrant. So when divided by 2 all over, theta is between 0 and pi implies theta over 2 is between 0 and pi over 2. So if theta over 2 is in the first quadrant, so all sine, cosine, and tangent are positive. So I just use the formula. This is 1 minus cosine alpha over 2 So my answer is 1 minus, remember cosine is already a negative number, negative 5 over 13 over 2. So I get 1 plus 5 over 13 over 2. So that is 13 plus 5 over 13 over 2. And that is square root of 18 over 13. 2 is 2 over 1, so that's 1 over 2. Simplifying, I get square root of 9 over 13, which is 3 over square root of 13, which is 3 square root of 13 over 13. That's your sine theta over 2. Now I do cosine theta over 2, so I write it as positive again, 1 plus cosine theta over 2. So that is 1 minus, because your cosine is a negative number, it's 5 over 13 over 2. So I get 1 minus 5 over 13 over 2, which is 13 minus 5 over 13 over 2. 13 minus 5 is 8. So that's 8 over 13 over 2, which is 2 over 1. So 8 over 13 times 1/2. That's 4 over 13, which is 2 over square root of 13. And that is 2 square root of 13 over 13. So that is your cosine theta over 2. Sine theta over 2 was 3 square root of 13 over 13. Cosine is 2 square root of 13 over 13. Tangent theta over 2, I can simply do the ratio. So sine was 3 square root of 13 over 2 over 13, and cosine is 2 square root of 13 over 13. So that's 3/2. You can actually use the half angle formula for tangent to do this problem, or so to say, you can say this is square root of 1 minus cosine theta over 1 plus cosine theta. Positive because theta over 2 is in the first quadrant. So square root of 1 minus it was 5 over 13 over 1 plus minus 5 over 13. So I get square root of 1 plus, minus times minus is a plus, 5 over 13 over 1 minus 5 over 13, which is equal to square root of 13 plus 5 over 13 all over 13 minus 5 over 13. So cancelling the 13 from top and bottom, I get square root of 18 over 8, which simplifies as square root of 9 over 4, and square root of 9 is 3, square root of 4 is 2, so 3/2 is your answer either way. Okay, that answers this question. Now we have a triangle given, we have a formula given, and we are going to use the figure to find the exact trigonometric ratio. So remember, this time the formula means the double angle formula for sine. So this is sine 2 times theta over 2, which is sine of theta. And sine of theta, I need the hypotenuse. So I will say r squared is equal to 12 squared plus 5 squared. So that is 144 plus 25. So r squared is 169. R is always positive, so taking square root it is 13. And sine of theta is opposite, so 12 over 13. The hypotenuse answers my question. X is between 90 degree and 180 degree, and cosecant x is 4. You want to know sine x over 2, cosine x over 2, and tangent x over 2. So if you are originally between 90 degree and 180 degree, and I divide all of them by 2, I get 45 degrees less than x over 2 less than 90 degrees. So x over 2 is in the first quadrant, so all three of them should be positive. And then I have cosecant x is equal to 4. So remember, your angle this time is in the second quadrant because you are 90 degree and 180 degree. Cosecant x is hypotenuse over opposite. 4 is 4 over 1. So the hypotenuse is 4 and y is 1. What is x? So x squared plus 1 squared is 4 squared. So x squared equal to 16 minus 1, so 15. And x, when I take the square root, I get absolute value equal to square root of 15. But x is second quadrant, which is negative, so it's minus square root of 15. So that tells me how much is cosine of x. It is adjacent side, so minus square root of 15 over the hypotenuse, which is 4. Sine x over 2, I know the formula. It is square root of 1 minus cosine x over 2. It's positive because x over 2 is in the first quadrant. So I get square root of 1 minus, your cosine is itself a negative number, so I can already make it a plus, square root of 15 over 4 over 2. So without doing much calculation, I can say that this is 4 plus square root of 15, and the bottom is going to be 8, and that is your sine x over 2. Square root of 4 plus square root of 15 over 8. When I'm doing the cosine rather for x over 2, it is 1 plus cosine x over 2. So that will be equal to square root of 1 minus square root of 15 over 8. Because plus times minus is a minus, and cosine itself was a minus number, and that should be a 4. I'm so sorry. 4 over 2. So similarly, you can say that this is 4 minus square root of 15 over 8 as the final answer. 4 minus square root of 15 over 8. Tangent is square root of 1 minus cosine x over 1 plus cosine x. Just remember that cosine itself is negative, so 1 minus become 1 plus square root of 15 over 4 all over 1 minus square root of 15 over 4, which is 4 plus square root of 15 over 4 minus square root of 15 under the square root, and that is the answer to the tangent. I have to express tangent pi over 8 as square root of a minus b. So it's a half angle formula first. So I will say tangent pi over 8 is in the first quadrant already. Or if you want to understand whether it's indeed in the first quadrant or not, what you would like to do is write pi and then divide it by 8 and then multiply 180 divide by pi to change it to the degree measure, and it's 22.5. So pi over 8 is in the first quadrant. So tangent pi over 8 should be positive. And it will be 1 minus cosine twice pi over 8, which is pi over 4, over 1 plus cosine pi over 4. So we did it previously. The algebra this time is going to be a little different. So it will be 1 minus square root of 2 over 2 over 1 plus square root of 2 over 2. And I know the calculation in the next step, I'm going to write it as 2 minus square root of 2 over 2 over 2 plus square root of 2 over 2 under square root. Cancel the 2 2's and you get 2 minus square root of 2 over 2 plus square root of 2. But remember, your answer should be of the form square root of a minus b. So what you do at this point, it's called rationalizing the denominator. So what does that mean? You write it as 2 minus square root of 2 on the top times 2 minus square root of 2 on the top over 2 plus square root of 2 on the bottom times 2 minus square root of 2 on the bottom. So I already have 2 minus square root of 2 over 2 plus square root of 2. I multiply top and bottom by 2 minus square root of 2. So on the bottom what I have is a plus b times a minus b. A plus b times a minus b, which is a squared minus b squared. So it's 2 squared, so 4 minus square root of 2 squared, which is 2. On the top, you simply have 2 minus square root of 2 all to the power 2. So it's easy to take the square root at this point. So I say this is equal to, on the top, as I said, it is pretty simple. On the bottom, you should simply have 2. And don't forget, it is still under the square root. So what you have is square root of the square on the top, and the bottom is 4 minus 2 with the square root. So then I can write it as 2 minus square root of 2 over square root of 2 and simplify as square root of 2 minus 1. So that's what I got. I have to compare it with this with the given form. Given form is square root of 2 minus b. So a must be 2 because that's square root of 2. And minus 1, so b must be 1. And that would answer my question. So this is what half angle and double angle formula is going to do for us. Our next problem is also a problem where cosine is negative and sine is negative, and we want to know the quadrant of the angle a over 2. Remember, sine and cosine are both negative in third quadrant. So you are between 90 degree and between 180 degree and 270 degree. That's the third quadrant. Or I can say between pi and 3 pi over 2. So divide all of them by 2. So what you get is pi over 2 less than a over 2 less than 3 pi over 4. And remember, 3 pi over 4 is just 135 degrees. So a over 2 is in quadrant 2. Sine of a, that's the first thing I want to know. Well, sine of a is going to be in third quadrant, and that is negative. So what I can do is do my little right angle triangle in the third quadrant. Remember, cosine is negative 0.91. One fascinating way to think about this problem is thinking about 0.91 as 91 over 100. That gives us the ratio. So remember, in third quadrant, both x and y are negative. So my y is this time, because this value is cosine of a, y is something that we're going to try to find out. X, which is the adjacent side, should be negative 91, and 100 is the hypotenuse. So y squared plus negative 91 squared equal to 100 squared. So y squared is 100 squared minus negative 91 squared, even though that's going to be positive. I will check that. So 100 squared, first do that, and then subtract 91 squared. So that's 1719, and I need to take the square root of this thing. So first I will write y squared equal to 1719, and as I said, I will now take the square roots on both sides. Remember, y is going to be negative. So first you will get absolute value, and then you will take the negative answer. So round to 4 decimal places, that's 41.4608. And that is my y. I would have absolute value, but I have to take the negative answer for y because I'm in the third quadrant. So sine of a is y over 100. So that's going to be minus 0.414608. Remember, it's going to be whatever we got, negative 41.4608. That's a y over the hypotenuse 100. So that is negative 0.414608. Sine a over 2, cosine a over 2, tangent a over 2. Second quadrant is a over 2. That's what we have found out. So sine is positive, cosine and tangent are negative. So let's do that. First, I do sine of a over 2. That should be positive. So this is 1 minus cosine a over 2. And I get 1. Because cosine already is negative, it's negative 0.91. So minus will make it a positive number, so that's 1.91 essentially. So I will say this is square root of 1.91 over 2. I take the square root and round to 4 decimal places. So let's see. I have 1.91 on the top. I divide it by 2, and then I take the square root of that. So this is 0.9772. That is sine a over 2. Cosine a over 2. Now this is going to be negative. Why? Because a over 2 is in the second quadrant. So minus 1 plus cosine a over 2. And I know cosine a is negative, so I get 1 minus 0.91 over 2, which is square root of 0.09 over 2. Rest I will do in calculator. So I get 0.09 divide by 2 and take the square root round to 4 decimal places. This is 0.2121. And remember, this is going to be negative all along. So minus 0.2121. For tangent, I'm not going to use the double angle formula or half angle formula anymore. It's the ratio of sine and cosine. So I would say tangent is sine 0.9772 over minus 0.2121. That's the easier way of doing it. So let's do that. 0.9772 divide by 0.2121, but that is negative. So I get negative 4.6073. The tangent value answering my question. Find an identity for cosine 4t in terms of cosine t. So I'm going to use repeated amount of double angle formula. What do I mean by that? Remember first, cosine 4t is 2 cosine square 2t minus 1, because the double angle of 2t is 4t. Then I would say this is 2 times cosine 2t to the power 2 minus 1. Use the double angle formula for one more time. You get 2 cosine t minus 1 as cosine 2t, and then you FOIL and distribute. So I get 2 times 4 cosine square t minus 4 cosine t plus 1 minus 1. Distributing the 2, I get 8 cosine square t minus 8 cosine t. Then I get plus 2 minus 1, which is a plus 1. So cosine 4t is equal to the identity of 8 cosine square t minus 8 cosine t plus 1. Sine pi over 2, write it in the form of 1/2 times square root of a minus square root of b. Then by using half angle formula, find a and b. Okay, what is pi over 2? So half angle formula means I will use a half angle formula, but I need to know in which quadrant pi over 12 is. So I will do pi divided by 12, then times 180, then divide by pi, and it's 15 degrees. So it's in the first quadrant, and the double angle is 30 degrees. So because sine pi over 12 is positive, I just use the formula 1 minus cosine 2 times pi over 12, which is pi over 6, over 2. And that is square root of 1 minus square root of 3 over 2 over 2, which is square root of 2 minus square root of 3 over 2 over 2. And we have seen it so many times now. This is going to be 2 minus square root of 3 over 2 times 1/2. So 2 and 2 multiplies and gives me 1/4 on the bottom. So 2 minus square root of 3 over 4. You can take this 4 out of the square root, that becomes 1/2, 2 minus square root of 3. And then I compare and identify. So A must be equal to 2 and B under square root, so must be equal to 3. And that will answer my question. T is between pi and 3 pi over 2, and I want to know the double angle formulas for cosine and sine. So first of all, cosine is negative, and t is between pi and 3 pi over 2, so that is t is in the third quadrant, so sine is also negative there. Real quick, we draw the right angle triangle. Cosine is the adjacent, -7, hypotenuse is the 8. I want to know the y. So y squared plus -7 squared is 8 squared. So I get y squared equal to 64 minus 49, and y squared is 15. So square root of y squared is absolute value of y equal to square root of 15. But y being negative in third quadrant, my answer is square root of -15. Negative of square root of 15. Cosine 2t is cosine square t minus sine square t. So that is equal to, cosine t is given, -7 over 8. Sine square t will be opposite, which is negative square root of 15 over hypotenuse, which is 8, and then simplify. So you get 49 over 64 minus 15 over 64, which is going to be 34 over 64. And I can divide both top and bottom by 2 and get 17 over 32 as cosine 2t. For sine 2t, I use the double angle formula, so that's 2 sine t cosine t. So I get 2 times, remember this is negative square root of 15 over 8 times negative 7 over 8. So I get minus times minus is a positive, 2 times 7 is 14, square root of 15 over 64. I can divide both top and bottom by 2 to get 7 square root of 15 over 8. That is sine of 2t. Should be 32, I'm so sorry. Divided 64 by 2 is 32. Half angle formula, cosine t over 2. So now I need to know where t over 2 is going to fall. Remember, t is in the first quadrant. It's between 180 degrees and 270 degrees. So t over 2, dividing all of them by 2, will be between 90 degrees and 135 degrees. So that's second quadrant. T over 2 is in the second quadrant. Sine is positive, cosine is negative. So when I'm doing cosine, I'm using negative of the formula. 1 plus cosine t over 2. I know 1 plus cosine t is 1 minus 7 over 8 over 2. So that's 8 minus 7 on the top, and the bottom is 16. And I can do the square root. It's going to be square root of 1 over 16, which is 1/4. Not forgetting, all of that is negative. So it is negative 1 over 4. For sine, second quadrant is positive. So it's square root of 1 minus cosine t over 2. And remember, because cosine t is already negative 7 over 8, I get 1 plus 7 over 8 over 2. So similarly, you get 8 plus 7 on the top, bottom is still 16. So I get square root of 15 over 16, which is square root of 15 over 4, and that's sine t over 2. And that will complete this question. And that ends our lecture for half angle and double angle formula. Clearly, this is a long section. There are relatively more problems in the homework sets. Start working. As soon as you have questions, let me know.